Telnet is an application used to establish a virtual terminal communication with another device. In this section, I'm going to go through just showing you the general Telnet packet structure. In the next section, you'll be doing filtering on Telnet, and then you'll look at normal Telnet traffic, and then finally you'll end up looking at some unusual Telnet traffic, which there's some great unusual Telnet traffic in that module. I'm going to open up a trace file called telnet.pcap. And first of all, we see that Telnet sits on top of TCP. So we see the handshake process take place, and the Telnet port is port number 23 by default. Once the handshake process is completed, then we see an actual Telnet data packet. Now the data packet may contain data, or it could contain commands. These commands establish the Telnet session and adjust the Telnet session as it moves forward. In this case, we have 4 Telnet commands. I'll go to the next packet, and here we have carriage return line feed, and then we have actual data just saying user access verification, carriage return line feed, and a request for a password. With Telnet traffic, it's much easier to just right mouse click and follow the TCP stream to see what's really going on. In this case, we have somebody connecting to a Cisco box, and they're sending the password. The password is rum and coke. It's interesting because they're not getting an echo back when they type in the rum and coke, but they are getting an echo back when they type in show version, and that's why we see it duplicated in there. We see the client sends the S and the server echoes the S back. The client sends an H and it gets echoed back, and that's why we see this striping pattern take place. The same thing happens in the exit, which is being echoed back to the client. Of course, if we wanted to only see one side of the conversation, we can click and say we only want to see the traffic going to the Telnet daemon, or we could say we want to see the traffic coming from the Telnet daemon. Again, Telnet traffic is pretty simple. It's either going to be sending data across the cable, or it's going to be sending these commands across the cable. As we look through the communications and scroll through, we can see do echo, do suppress go ahead, I will do this, I won't do this, send me your terminal type. My terminal type is ANSI. And then all of a sudden we'll start seeing the data, and here we see the password going across, RUMAND. And there we saw two bytes going across in one Telnet packet. We don't always have to send across a single byte, but we will when we're echoing back and forth, sending a single packet and waiting for the echo back, and sending a single packet and waiting for an echo back. In the next section, we'll work on filtering on Telnet traffic. In this module, we're going to start out by filtering on Telnet traffic using a capture filter. Then I'll use a display filter, and then finally I will filter on specific information inside of a Telnet frame. So I'll click on the Capture Options button to make sure I don't have any filters already in place. And I'm going to look at the capture filter listing to see if there's a Telnet filter already built for me. I don't have a Telnet filter in there, so I'll have to build one myself. So the filter name will be Telnet, and the filter string will be TCP port 23. That's the default port for Telnet traffic. I'll click New. I see it up on my list above, and I'll say OK. There's the filter, and now I'll click Start. Now I'm going to toggle over to the DOS prompt so that I can telnet to a server. From here, I will telnet to torfree.net. Oops, I didn't type that right. torfree.net. Says I'm connected. I need a login. I'm going to log in as guest. And there's the Toronto Freenet, information about membership and services. And I'm not going to go any farther. I'm going to go ahead and hit Q to quit. Yes, I do want to quit. And it tells me the connection to the host is lost. So now I want to see the traffic that generated. Here we can see there's the handshake process. Everything looks good, and there's my telnet data. Now I'm going to stop capturing and I'll save this trace. And I'm going to save it with the name of telnet tour free PCAP. Now I want to open up a trace file and apply a filter for just the telnet traffic in that trace file. First, I'll click on Open a Capture File. I'll select telnet, and I'm going to batmud.cap. And now it's opened up the batmud.cap telnet communications. Now you can see I've got some HTTP traffic in there, as well as some telnet traffic, and I've got some DNS traffic as well. So in the display filter area, I'm just going to type telnet and hit enter, and now I'm just looking at my telnet data traffic. Now I didn't get the handshake traffic though, because of the way I built that filter. If I was interested in getting the handshake traffic up here, then one of the better ways might have been to build a filter based on the port information. So I'll right mouse click on the destination port of telnet, say I want to prepare a filter based on the selected value. Now it put in TCP DST port, destination port, but I really want any traffic to or from port 23, and I'll apply that filter. Now I've got the handshake process, plus I have the telnet data process as well. Now as I look through the telnet information, I'll collapse the TCP area. Maybe I'm interested in, after the handshake, looking for specific characters such as carriage return line feed in the first line of the telnet packet. In that case, I'll right mouse click, prepare a filter based on the selected value. And you can see that this is a very strange filter here. I'm looking 54 bytes into the frame, which is the first byte after the TCP header. And I'm looking for a 2-byte value that contains 0D0A. That's carriage return line feed. I'll apply that filter, and now the only packets I should see are packets that have the carriage return line feed in the first and second data byte positions after the TCP header. The problem with filtering on some telnet traffic has to do with the order in which the information is going to go back and forth. Because what you'll find is that even when telnet terminals are doing negotiations up front, the order in which they define the negotiations that they want to perform may be different with every different connection that you make. In the next section, we're going to analyze normal telnet traffic. In order to show how normal telnet communications works, I'm going to open up a trace file called telnet.pcap. Now I can tell you, going through here with the information that goes back and forth between the telnet client and the telnet server, I'm going to get confused as to who is saying what. So I'm going to put in a quick coloring rule to state that all traffic from the client should show up with red text on a white background. So the first thing I'll do is I'll select the source address of the client, right mouse click, prepare a filter based on the selected. I'm only doing that just so that I can copy and paste that in. I don't have to type it in. Now I'll select View, Coloring Rules. I'm going to make a new rule, and this rule will be for the telnet client. I'll tab down to the string line and paste the information in. The foreground color, I want it to be red, and the background color is already set as white. Say OK, and that rule is added to the bottom of the list. Now, in order for that rule to be processed before the ones above it, I have to move it up. So I'm going to move it up to the very top of this whole entire coloring rules list. And I'll say Apply and OK. Now it's easier for me to view this, to figure out what's going on as I go through it. So we have the three-way handshake at the beginning, and let me clear out that filter, I wasn't using it. The three-way handshake at the beginning, and then we have traffic coming from the server first. Now, in the telnet traffic, let me close this IP header. In the telnet traffic, telnet sits on top of TCP. And here's the server sending the packets from port 23, the telnet daemon port. And the first thing the server does is it says will echo, will suppress go ahead, do terminal type, do negotiate about window size. And if you're going to analyze telnet communications, you have to understand will, won't, and do, don't. Will and won't is what the sender says it will and won't do. Do and don't are demands made of the other side of the communication, the target. So in this case, the server is saying that it will echo and it will suppress a go-ahead. A go-ahead was used for half-duplex communications where only one side could talk at a time. So one side would say something and then say go-ahead at the end of that, and then the other side was allowed to talk. Now, the server is also saying do terminal type, tell me about your terminal type, and do negotiate about window size. We'll see in a moment that's not really going to work the way we want it to. Now, I don't need the bytes area down below, so I'm going to clean that up by getting rid of the data bytes. That's much better. Now, the server also says in a second packet, carriage return line feed, and then a banner, user access verification, carriage return line feed, and then it prompts the client for the password. But the client sends back an ACK, and immediately after that, it says to the server, do echo. Well, up here, the server's already said it will echo. Now the client is saying, hey, I want you to echo. That's great. Scroll down a little bit. Here we see the server just sending an ACK packet back. Now the client says send some information back to the server. And even though it says telnet data, this is actually a set of telnet commands. So the client says do suppress the go ahead. And it says it will do the terminal typing requested, but it won't negotiate about window size. So this is something the client says it won't do, even though the server told it wants it to do that. Now, the client also says do suppress the go ahead, and we can go up above and see what that server said about suppressing the go ahead. It said it will suppress the go ahead. So they agree on that. They don't agree on the negotiate window size. The client says it won't do that. The server asked it to. Now the server sends a packet to the client saying, sub-option begin, terminal type, send me your terminal type information. The client says, I'm an ANSI terminal type. At that point, the server comes back and says, okay, don't negotiate about the window size. Well, the client said it won't anyway, so the server's agreeing with the client. Now we see an ACK go back from the client to the server, and the server sends back an ACK to the client, and the client at this point says, okay, I won't negotiate about the window size. Back and forth about this window size stuff. We've got an ACK going across the cable, and then suddenly we have real data crossing the cable. So we have the letter R going across the cable from the client to the server. The server acknowledges receipt of that. Does not echo it back though. Then the client sends a U, the server sends an ACK, just a simple ACK. The client sends an M, server says ACK, client sends A, ACK, ND. Now we have two characters going across in that telnet packet. The server says got it, and then the client CO, server says got it, and KE. Now when you go through telnet communications, if you really want to see the data that's being exchanged, the best way to do this is to right mouse click on the window up above and say that you want to follow the TCP stream. Now, the thing that you won't be able to see are all those commands going back and forth, but you will see the actual true data going back and forth between the two. So here we can see there's the terminal type, ANSI, and we can see rum and coke is the password. And in this portion where we see it striped between red and blue, the red is the client, the blue is the server. This is what it looks like when the server echoes back characters sent from the client. We can see the server send all the information down to the client, and then the client typed in exit, but it made a mistake in exit. So we can see E, and then it got echoed back, and I was sent echoed back, and then space, echoed back, and the little mistake in here, and the client had to do some backspacing to get it to say exit. Now, in this window, if we want to, we could say that we just want to see one side of the communications, such as the traffic coming from the client to the server, and that's what the client said to the server. Or we could see just what the server said back to the client. I'm going to close this window down, and I just want to show you that when those commands are going across the cabling system between the client and the server, when I bring up the hex view, the packet bytes view, you'll see that all of these commands start with an FF at the beginning of them. But the problem is, if we want to filter on that, we aren't sure how many commands are going to be in one of these packets. So here we can see we have a command, do suppress go ahead. There's the command FF, it starts with. Terminal type starts with FF. Won't negotiate about window size, starts with FF. So the problem we have in pulling that data out is that we don't have the static information all sitting right at the top, and we don't know how many of these entries are going to be there. This is still a normal telnet communication. We've got the commands going across the wire, then we've got data going back and forth between the two devices. In the next section, I'm going to show you some unusual telnet communications, including a failed login and when somebody hits the telnet port and it's being refused. There are two different ways that I can show you on how a telnet connection might be refused, one using ICMP and one using TCP reset. And then I'm going to show you some really funny telnet traffic. Now I'm going to open up and show you a series of trace files where we have problems with telnet communications. The first one I'm going to open up is telnet refuse via reset. Now in this case we have someone trying to make a telnet connection to a target system, but that target system is sending a reset back saying, no, I don't support the telnet daemon. That's a normal refusal. This client never even got to the point of trying a login or a username or a password or anything. It appears that the target system is not supporting port 23 services telnet on port 23. So the next trace I'm going to open up is called telnet refuse via ICMP. And this is an interesting trace because we have a system, somebody that's going out and doing a telnet operation to a machine. And let me open these up just a little bit so we can see these more clearly. In this case, we can see that the client is 12.234.13.89, and I'll just refer to them as the 89 device, and they're telnetting to this 151 device. But we have a 192.67.240.234 device that answers back. We didn't even get an answer back from this 128.121.70.151 device. We got an answer back from someone entirely different. And that answer was an answer back from a device that is telling us that it is filtering our traffic. It says destination unreachable and a code 13, communication administratively filtered. Let me tell you, if you're filtering somebody's traffic, you don't want to let them know it. It's much better just to drop the packets than to turn around and tell them, I'm sorry, this door is locked because there's something important on the other side. So this is crazy to see that on the cabling system, and you really shouldn't see that. A decent filtering device should just drop the packets, not tell you that they're filtering those packets. So this is kind of an interesting trace to see that weird ICMP traffic. Now let me show you what happens when we connect to a telnet server, but we've got a problem with the login process. I'm going to open a trace now called telnet failed logon. And in this trace file, we see the handshake process occur. There's a three-way handshake. Everything looks good there. And then we see some of the commands, the options, the negotiation going on. I'm going to just right mouse click so I can see what happened in the whole entire telnet session. And I'll follow the TCP stream. And there is what happened. We see there's the banner coming down, Georgia Softworks, Telnet server for Windows, blah, blah, blah. Evaluation copy, the expiration date is, yes, this trace was taken a while ago, but it's nice because it shows the login didn't work. So there we've got the terminal type of ANSI, and we can see that the login that they tried was admin, and it's being echoed back because we see that striping between red and blue and red and blue and red and blue. And then they tried a password. Now, the password is being echoed back with asterisks. So the user typed in A, and then it got echoed back with an asterisk. And then the user tried M, echoed back an asterisk, I, N. So the user tried AMIN, which was being echoed back, but the user obviously meant to type admin. These are backspaces, and we can see DMIN. So the user tried admin, and that login failed. The server said, please try again, and gave the user the login prompt. I'm going to close that window down and clear out the filter. And now I'm going to show you a really strange telnet communication that didn't go well because the two sides are bickering and fighting about the options and setting up the telnet communications. This is called telnet-questionable. Now this is one of those trace files where I'd really like to color code the communications so that I don't get messed up with who is talking to whom. So in the IP header portion, I'm going to right mouse click, prepare a filter based on the selected value just to pick up that traffic so I don't have to type it in. I'm a terrible typist, so I'll do anything I can to avoid typing. I'll say View, Coloring Rules, and I'm just going to edit the coloring rule that I placed in on the last module. Come up here, and I'm going to paste the new address. I'll say OK. I can see it's changed. I'll apply it to the traffic in the background and click OK. So now I've got it set so that my client shows up in red traffic. So let's look at what happens. We have the three-way handshake that takes place. Now, first of all, the time column setting you need to understand here. My time column setting is showing me when each packet arrived compared to the first packet in the capture. Look how slow this process is. There's the first packet of the handshake, and 3 seconds later, we got the second packet of the handshake. And then a couple of seconds later, we got the third packet. So here, this is a retransmission here right away. Here's a SYN packet going out saying, I want to make a handshake. No answer. And here's a SYN packet going out again. And then it took over 2 seconds before the SYNAC came back. Ooh, that doesn't look very good at all. I'm going to change the time column setting so that it shows me from the end of one packet to the end of the next packet. Look at these delays. There's the first SYN packet. 3 seconds later, it's a retransmission of a SYN packet. Took 2.2 seconds for the SYNAC to come back. Ugh, that's really ugly. And then after the handshake completed successfully, it took 3.2 seconds for the server to talk back to the client again. This is definitely not going to go well at all. And we can see a retransmission in there a little bit further already. So let's look at what happened. And I'm going to get rid of the hex window because we don't need to see the packet bytes as we look at this. I'm also going to collapse the IP header area so we can just focus on telnet. So as we go through this communication, we see the server sending this do terminal type, do terminal speed, do X display location, do new environment option. So it's demanding that the client do all of these things in packet number 5. The client turns around and says, well, I'll do the terminal type. So they agree on something, and that's good. Now here the server turns around and says, look, do terminal type, do terminal speed, do X display, do new environment. This is a retransmission of the previous request from this server that the client do all these things. At this point we have a duplicate ACK. We've got another ACK in there. Now we're looking at communications from the client. The client says, well, that's really nice that you want me to do terminal speed and you want me to do X display location and you want me to do new environment, but I won't do any of those things. So we have a little disagreement between these two. The server acknowledges receipt of that information and then says, send me your terminal type. Client says acknowledge, and the client says, okay, here's my terminal type. I'm a DEC VT100. Server says, okay, now listen. I'm going to suppress the go-ahead, and you need to do echo, and you need to negotiate about window size, and I will do status information. I will accept status information and do remote flow control on your side. Now, will status is kind of interesting, which means I will continue to negotiate these options. When you see somebody saying don't status, that means, you know what, I refuse to talk about these options anymore. I'm done with it. Let's go on and do data. So we're not at that point yet, but we will be. Look at the time that's going by. We see an ACK from the client, and we see the client saying, don't suppress the go-ahead. The server says, I will suppress the go-ahead. The client says, don't suppress the go-ahead. And the server comes back and says, I don't care what you say. I will suppress the go-ahead. I'm not going to send you this little go-ahead communications. So they're bickering back and forth about this go-ahead process. The client then responds to the server and says, look, I won't negotiate about window size. I won't echo. Don't do the status stuff. Don't talk anymore about the status stuff. And I'm not going to be doing flow control. Geez, these guys just go back and forth forever. Look how long it's taking. Server comes back and says, look, no, sorry, the client comes back and says, I won't echo, I won't negotiate, don't do the status, won't do the flow control. Oh, and by the way, I forgot to tell you in that last packet, this is a retransmission here, but it actually adds data to it. It says, I also don't want you to suppress the go-ahead. We've got packet loss in here. And finally, in packet number 22, we get to the point where the server finally turns to the client and says, you know what, I will echo, and this is the information about who I am. Now, all of this option process sort of ended when the client sent this thing across saying, look, don't status. That's the client saying, I don't care anymore about these options. We've got to get moving forward from this. So that don't status was important to see. Now we see the login prompt. And at this point, I don't want to see any more of the negotiations go on. I want to see what data crossed the wire. So I'll right mouse click and follow the stream. And all we got up to for all of that time was just the stinking login prompt. Unbelievable. I'm going to close this window down. I'm going to change my time settings to show me when packets arrive from the beginning of the trace file. I clear out my filter. The beginning of the trace file, we're at 0 seconds. And when we got down to the point of actually having the login prompt, that didn't occur until packet number 24, 26.6 seconds into the trace. That is horrible. I'm surprised that this user would even ever want to telnet back into that server again. So that's a really lousy communication. And half of it was because these two are fighting back and forth about the options. Now the final trace file I'm going to open up for you is one called telnet-funny. Now, when we look at this trace file, we see the DNS query go out, and then we see the handshake process. And after the handshake process, we see these really strange characters. Now, these characters are to blank a screen. And we see this blanking a screen, line feed, got acknowledgments, and then suddenly we start seeing this text come up saying, the hard work was done by Simon and Mike. I just placed it online in a different format. So they typed in this data, and then we have carriage return line feed. So long and thanks for all the fish. So you probably recognize that. Hitchhiker's Guide to the Galaxy. Then we have a blanking of the screen. IP6 version has extra scenes and extra color support. So if you want to experience ASCII Star Wars to its fullest, you should really get IPv6. Okay, so there's a real great reason to move up to IPv6 if you want to go to this website and experience this. And the best way to see what's happening in here is to right mouse click and follow the TCP stream, let it build it for you, and you can actually scroll through the whole entire Star Wars scene that they put all this time into in ASCII text. There's a flashing screen that starts out saying 20th century text, 20th century text. Once that is all done, then we'll see Star Wars Episode 4, A New Hope. We can see the data goes scrolling by. There's a lot of work these guys put into this. And then you begin to see the actual pictures of what's going on. You'll see the little starships, and you can see this when you scroll fast. So there, it's a very strange site, but it's interesting to see what they've done, and it's all done with telnet. Isn't that crazy? I hope you won't see that kind of telnet traffic on your network, because that's really unusual telnet traffic.